In the world of electric vehicles, Tesla has reigned supreme, but its days as top dog may be numbered.
For all you range extender electric vehicle and plug-in hybrid electric vehicle owners out there, when buying your car, you're likely focused more on the combined range and power.
Brace yourself for the shockwave that is about to rip through the electric vehicle world.
So Electra is growing very fast. We are reaching 50 people. We're going to double by the end of this year. We have great partners, including BlackBerry.
After a rumored statement from BYD's CEO claiming Tesla's latest engine could destroy rival EV makers, attention has skyrocketed. This carbon-wrapped beast reportedly delivers unheard-of speed, efficiency, and range, threatening to reshape future transport. Is it a true market annihilator or hype? Strap in, because this engine saga is packed with twists, turns, and electrifying secrets. Carbon fiber wrapped. Rotor, a game-changing innovation. Carbon fiber is changing the electric vehicle world in ways that few anticipated, and Tesla's newest carbon fiber wrapped rotor is at the center of this revolution. According to rumors, even the BYD CEO believes this cutting-edge motor design could disrupt the entire EV industry. The core advantage lies in how carbon fiber reinforcement shapes the rotor's performance, allowing higher rotational speeds and improved reliability. Traditional motors depend on metal parts which expand under heat, risking structural weakness over time. In contrast, carbon fiber technology fights these challenges, keeping the rotor intact even under extreme stress and temperature changes. By adding a carbon fiber sleeve around the rotor, the design reaches revolutions surpassing 20,000 per minute. This astonishing speed ensures quick acceleration on par with hypercars, and it boosts overall efficiency. Drivers can see better range and less heat buildup, directly attacking the fears of limited battery life. The rotor's lightweight nature also cuts down on vehicle mass, leading to smoother handling. If this technology becomes widely adopted, it might be the final push electric vehicles need to overtake combustion engine cars once and for all. Manufacturing such a complex rotor, however, demands precise engineering. Carbon fiber and metals expand differently when heated, so advanced robotics and machine learning are required to wrap the rotor without errors.
One of the first things we're interested in is perception. How does the robot see the world? So we've got cameras in each of the eyes, we've got beamforming microphone which kind of behaves like human ears.
Yet Tesla's open-source policy encourages other automakers to explore these designs, potentially sparking a wave of innovations across the market. If competitors do not embrace it, they risk lagging behind in both performance and consumer demand. Critics question the safety behind such high-speed capabilities, but supporters argue that the rotor's lightweight design and lower operating temperatures reduce many mechanical hazards. Instead, regulatory bodies may need updates to handle these next-generation vehicles. If the excitement holds true, we might see electric cars dominating racetracks and highways sooner than expected. For BYD's CEO, the fear that this new motor will destroy the existing EV landscape stems from worries about unsustainable competition. Will smaller manufacturers survive if they cannot match this level of engineering? While that remains uncertain, one thing is sure: carbon fiber-wrapped rotor technology has opened a door to possibilities once seen as futuristic dreams. Whether this approach forever changes the EV market depends on how quickly rivals adapt. In the meantime, enthusiasts everywhere watch with fascination as the next phase of electric mobility unfolds right before our eyes. These groundbreaking innovations remind us that progress never stops, and the best is yet to come for EV enthusiasts. Unmatched acceleration and efficiency. One of the biggest breakthroughs in electric vehicles is Tesla's new engine design, which some experts claim could revolutionize the entire industry. According to rumors, the BYD CEO even suggested that this advanced motor might destroy rival manufacturers who cannot keep up. What makes it stand out the most is its unbelievable acceleration, letting vehicles rush from 0 to 60 miles per hour in just around 2 seconds. This lightning-fast start is not limited to track conditions. It represents how modern electric cars can deliver power that was once only seen in high-end sports cars. Even so, it signals unstoppable progress. Behind this explosive performance lies the carbon fiber-wrapped rotor, built to handle extreme rotational speeds. Traditional metal-based parts tend to expand under heat and degrade over time, but carbon fiber reinforcement fights this issue effectively. As a result, the rotor can reach over 20,000 revolutions per minute without losing integrity. Drivers benefit from both raw power and longer-lasting reliability. This boost in power also unlocks impressive energy efficiency, because each rotation transfers more useful torque to the wheels. In simpler terms, every drop of battery power counts for more miles on the road. Tesla claims it resets industry limits. The concept of unmatched acceleration and efficiency goes beyond mere speed records. Better torque delivery means shorter charging stops, since each trip uses less energy overall. This appeals greatly to drivers who worry about running out of battery during long journeys. By cutting down on waste, the new design helps vehicles travel farther while burning through fewer kilowatt hours.
Telling people that buying an electric car is a great way to fight climate change is a pretty reliable way to start an argument in some circles. People will say that you still burn fossil fuels with electric cars, it just happens at the power plant instead of the engine.
That balance between performance and economy is key to gaining mainstream acceptance of electric transportation. For many, the biggest hesitation with EVs has been range anxiety. Yet with these breakthroughs, range and thrill can finally coexist without sacrifice. Even skeptics are paying attention. That is why the BYD CEO's warning seems so timely. If other automakers cannot develop or adopt similar technology, they risk being left behind. Tesla's carbon fiber-wrapped rotor highlights the future of electric cars. Lightning-fast acceleration, matched with a smart use of energy. While some competitors might attempt to catch up, the result could be a fierce race defined by constant innovation. In the end, drivers benefit from vehicles that offer jaw-dropping power without sacrificing practicality. Unmatched acceleration and efficiency are no longer distant goals. They are quickly becoming the new normal, shaking the entire EV landscape. All that remains is to see which brands can truly keep pace and survive. Engineering precision beyond rivals. Engineering precision beyond rivals is the quiet force behind Tesla's newest EV engine. The advanced carbon fiber rotor design allows astonishing speeds and superior reliability. Some, including BYD's chief, believe this breakthrough might destroy the EV market for any company unable to match such cutting-edge quality. This design focuses on wrapping the rotor in carbon fiber to handle massive rotational stress. Classic motors, often metal, risk expansion and damage under extreme heat. By contrast, a carbon fiber sleeve remains stable at higher temperatures, reducing wear and delivering more power without wasting energy. As a result, Tesla's new motor can spin beyond 20,000 RPM, giving it quick bursts of speed while staying reliable. That translates into faster acceleration, improved range, and reduced energy loss. It also means owners can drive longer distances, which helps calm fears about running out of battery on trips.
Another draw of sodium-ion batteries is that they have a longer cycle life, meaning that the battery can be charged and discharged more times than lithium-ion batteries and can operate in a wider range of temperatures.
Engineering precision becomes even clearer when you consider how carbon fiber and metals expand at different rates. Tesla overcame this by carefully researching each component's behavior under heat, then using robots to wrap the fiber accurately. Even a small error in fitting could weaken the rotor and ruin performance. Many believe that mass production of such a complex design is the ultimate test. But Tesla's gigafactories seek to solve that challenge through advanced machinery and data-driven systems. By analyzing the ideal tension and temperature for each wrap, they ensure every rotor meets strict standards, preserving accuracy on an industrial scale. For competitors, matching these methods might require huge investments in equipment, software, and training. BYD's CEO suggests this engine could leave many makers behind. If rivals fail to develop a system just as precise and efficient, they risk drifting into irrelevance while Tesla continues to set new benchmarks for EV performance. This success also pushes the entire industry to pursue stronger materials and refined assembly practices. Newcomers may need to license or borrow ideas from Tesla's open-source patents, yet replicating the exact manufacturing steps is not easy. The carbon fiber wrapping process calls for pinpoint accuracy that only advanced robotics can achieve. In the end, engineering precision beyond rivals is what sparks the fear that Tesla's engine will destroy the industry. Brands that stand still risk being overshadowed by a new era of high-speed and energy-saving EVs. The question is, can others rise to this challenge, or will Tesla's precise methods define the future alone? Time will tell whether rivals can master this balance, or if Tesla's unmatched engineering becomes the standard. A potential shift in the EV market. A potential shift in the EV market is on the horizon, fueled by Tesla's groundbreaking plaid carbon-wrapped rotor engine. This new innovation promises to redefine the electric vehicle industry, leaving rival automakers scrambling to catch up. Even BYD's CEO has reportedly expressed concern, claiming this engine has the potential to destroy the competition. But why is this such a big deal? And how could it reshape the EV market as we know it? At its core, Tesla's new motor addresses two major consumer concerns: speed and efficiency. The carbon fiber-wrapped rotor allows Tesla's vehicles to achieve unmatched acceleration, with the Model S Plaid hitting 0 to 60 miles per hour in just 2 seconds.
I just Plaid out to Laguna Seca on Sunday. I got a minute 30, and we think probably there's another 3 seconds or more to take off that time. So we're confident the Model S Plaid will achieve the best track time of any production vehicle ever.
But it's not just about speed. The motor's design also boosts energy efficiency, allowing drivers to travel farther on a single charge. This strikes at the heart of range anxiety, a long-standing hurdle for EV adoption. With Tesla leading the way in combining raw power with practicality, it's no wonder the industry is bracing for a major shakeup. This technological leap is not just about performance. It's also about precision. Tesla has pushed the boundaries of engineering by overcoming challenges associated with integrating carbon fiber into the rotor. Carbon fiber and metals expand at different rates under heat, making it difficult to marry the two materials without compromising durability. Through advanced robotics and machine learning, Tesla has mastered this process, producing engines that operate flawlessly under extreme conditions. For competitors, replicating this level of precision will be a costly and time-consuming challenge. The market implications are significant. If Tesla's motor becomes the new standard, other EV manufacturers will face a tough choice: invest in similar technology or risk falling behind. Smaller automakers may struggle to keep up, while established brands like Ford and GM could be forced to rethink their strategies to remain competitive. Tesla's decision to make its patents open source offers an opportunity for others to adapt. But scaling such advanced technology is no easy task. This shift also has the potential to influence industries beyond automotive, from aviation to renewable energy. However, the more immediate impact will be felt on the roads. With Tesla's Plaid motor setting new benchmarks, the EV market is at a crossroads. Will competitors rise to the challenge, or will Tesla's dominance reshape the industry entirely? The threat of market obsolescence. The electric vehicle, EV industry, is on the brink of a major transformation, and Tesla's latest innovation, the Plaid carbon-wrapped rotor, may be the catalyst for what some are calling a market shakeup. This revolutionary motor, capable of exceeding 20,000 RPM, is setting new standards for speed, efficiency, and durability. However, it's also sparking fears among competitors. The BYD CEO reportedly claimed that Tesla's groundbreaking motor could destroy the EV market for companies unable to keep up. The threat of market obsolescence has never been more real. The heart of this issue lies in Tesla's ability to innovate beyond what most automakers can achieve. The carbon fiber-wrapped rotor is a prime example of engineering precision, enabling Tesla to deliver unmatched acceleration and improved energy efficiency. With the Model S Plaid, Tesla has already proven this motor's capabilities, achieving 0 to 60 miles per hour in just 2 seconds. This isn't just a performance milestone, it's a statement that Tesla is pushing the boundaries of what EVs can do. For other automakers, this creates an enormous challenge. If they can't match or exceed these advancements, their current EV offerings risk becoming obsolete. Traditional EV motors made from metals like copper and steel face limitations under high stress and heat. Tesla's carbon fiber-wrapped rotor overcomes these issues, offering superior durability and performance. However, replicating this technology is no simple feat. The process of wrapping the rotor with carbon fiber requires advanced robotics and meticulous engineering. This level of precision is costly and time-consuming, putting smaller automakers and even established brands like Ford and GM at a disadvantage. For companies that lack the resources or expertise to innovate at this level, the threat of obsolescence looms large. The implications extend beyond individual automakers. A shift in consumer expectations is underway. Drivers are beginning to demand not only better range and efficiency, but also thrilling performance. Tesla's latest motor delivers all three, setting a new benchmark. Companies that fail to adapt will struggle to remain competitive, potentially leading to closures or significant losses in market share. As Tesla continues to refine its technology and scale production, the gap between it and its competitors may only widen. The EV market is evolving rapidly, and those who can't keep up may find themselves left behind. This is the harsh reality of innovation. It rewards the bold and leaves the rest in its wake. The broader implications of Tesla's technology. Tesla's groundbreaking Plaid carbon-wrapped rotor engine isn't just disrupting the electric vehicle (EV) market. It's setting the stage for a technological revolution that could impact industries far beyond automotive. With its combination of speed, efficiency, and engineering precision, this innovation is more than just a new motor. It's a glimpse into the future of sustainable technology. Even the BYD CEO's statement that Tesla's new engine could destroy the competition reflects the ripple effect this breakthrough could have on the global economy and industrial landscape. At its core, Tesla's motor represents a leap in engineering that pushes the boundaries of what's possible. The use of carbon fiber to reinforce the rotor allows for incredible rotational speeds, over 20,000 revolutions per minute, while maintaining durability and reducing weight. This translates into not only faster acceleration and improved performance, but also greater energy efficiency. Beyond the roads, this kind of precision and lightweight durability has applications in industries like aviation, where reducing weight while maintaining power is critical. Could Tesla's innovation inspire the next generation of electric aircraft? It's a possibility that's hard to ignore. The implications don't stop there. Tesla's focus on efficiency and range could also influence renewable energy systems, particularly in areas like wind turbines. Lightweight, high-speed motors capable of operating under extreme conditions could improve the efficiency and longevity of energy generation systems. If Tesla's motor technology is adapted for these uses, it could accelerate the global shift towards sustainable energy sources, furthering the company's mission to reduce reliance on fossil fuels. However, with innovation comes challenges. Tesla's technology sets a high bar that competitors will struggle to match. Brands like Ford, GM, and even BYD may need to invest heavily in research and development just to stay relevant. Smaller automakers, lacking the resources to compete, may find themselves forced to exit the EV market entirely. This shift could lead to a consolidation of power in the hands of a few companies that can meet these new standards, potentially reshaping the competitive landscape. Tesla's Plaid motor is more than just a technical innovation. It's a reminder of how one breakthrough can redefine entire industries. As its potential expands beyond cars, Tesla's carbon-wrapped rotor could become the foundation for a new era of sustainable high-performance technology. Whether on the road, in the air, or powering cities, this is only the beginning.
Nowadays, there are so many car manufacturing companies competing for supremacy. Recently, the CEO of General Motors has made an announcement that might just destroy the entire car industry.
We had a constraint with modules. We have addressed that. We're on track for the first month, and by the middle of the year, that should be well behind us.
Their latest engine is said to have the potential to change everything about car transportation. What powers might this new engine have to cause such a drastic change? Join us as we reveal all you need to know about the new GM engine that will destroy the entire car industry. The new engine from GM. With its new compressed air engine, General Motors has taken a big step forward. It's unlike anything else the car business has seen in the last few years. It might look like a normal engine at first glance, but it works in a completely different way. This engine doesn't use fuel or electricity. It runs on compressed air. GM thinks this new idea could change the way we think about transportation, especially as people around the world look for cheaper and cleaner options for regular cars. It's surprising how easy the idea behind this engine is. High-pressure air is compressed and held, and then it is slowly let out to power the engine. A device called a pneumatic engine does this. It works a lot like a regular internal combustion engine, with pistons. But instead of an explosion, air under pressure is pumped into the cylinder to move the pistons. It gets even more interesting. If you raise the air pressure, it moves the piston outward. A spring attached to the piston pulls it back into place when the air is let out. The car moves back and forth, and the cycle ends without any fuel being used. This design isn't just neat, it works well and doesn't cost too much. The engine doesn't put out any pollution because it doesn't need oil or diesel. It also doesn't take any rare or expensive materials to make compressed air, unlike the materials used to make batteries for electric cars. GM's plan could make this technology easier for people all over the world to get and cheaper for them to buy. This technology has been around for longer than you might think. In the 1800s, people first tried using compressed air engines. They were even used in mine trains and some European city trams. But over time, internal combustion engines took over because they could provide power more quickly. Compressed air technology didn't come back until the early 2010s, when a French company started exploring hybrid engines that used both compressed air and more traditional designs. Even though those ideas didn't catch on with many people, they interested GM, who wanted to bring the idea back to life and make it better. The way that GM's new engine has been improved to meet current needs is what makes it stand out. Because the design is so much like internal combustion engines, it can be made with tools and methods that are already in use. This speeds up the development process. At the same time, the compressed air system gets rid of many of the problems that come with older engine types. This engine doesn't burn fuel at all, so it doesn't have to deal with the waste and smog that come with that. It also doesn't have the high prices and resource problems that come with batteries for electric cars, which makes it a strong competitor in the market today. The engine is new in and of itself, and it also fits right in with GM's bigger plans. The business has been putting a lot of money into environmentally friendly products, like electric cars. Rather than focusing on just one solution, GM is looking into a number of ways to cut down on pollution and make the company more efficient. The compressed air engine is another piece of that puzzle, giving people another choice besides EVs. By working on this technology, GM is setting itself up to be a leader in new ideas and ready to meet the needs of a world market that is very diverse. GM is putting a lot of money into the idea that compressed air technology can be used instead of both gas engines and electric cars. Let's take a look at the benefits of this engine and how it is set to revolutionize the car industry, because you won't believe the extent it has gone to do this. The benefits of the compressed air engine. This brand new compressed air engine looks like it will be a big deal, and not just for the auto industry. The first great thing about this engine is that it doesn't pollute the environment at all. Unlike gas or diesel engines, it doesn't pollute the air with dangerous fumes and doesn't need to burn fossil fuels. This alone makes it a very appealing choice for people who care about the environment. When you compare it to electric cars, the environmental benefits are even greater. EVs don't cause pollution when they're driving, but the energy they use often comes from grids that are powered by fossil fuels. It's also hard to make EV batteries because you have to mine for rare earth materials. These things can be bad for the earth. All of that doesn't matter with engines that use compressed air. They run on air, and the process of pressing the air down can even be driven by clean energy sources like the sun or wind. It's better for the environment this way. This engine also does a great job when it comes to price. Putting together a compressed air engine is cheaper than putting together an ICE or an EV motor. Why? This is because compressed air engines don't need as many solid materials as combustion engines do because they work at lower pressures. The metals that are used can be simpler and less expensive, which lowers the cost of production. Because of this, car companies can make cars that are not only cheap to make, but also cheap to sell. Another big plus is that the engine is very simple to design and build. Less wear and tear over time means less maintenance costs because there are fewer moving parts. That means cars will have to go to the mechanic less often and require fewer repairs. Then there's how versatile it is. Small passenger cars aren't the only ones that can use compressed air engines. They can be used in many types of cars, from small city cars to big trucks or business vehicles. Because the technology is so adaptable, it can be used for a wide range of purposes, from personal transportation to heavy-duty tasks. This means that customers have more options and can find solutions that fit their needs. Another easy benefit is refueling or charging these cars. You're not connecting to the grid or stopping at a gas station. You're just squeezing air together. Renewable energy can be used to power the tools needed to do this. To put gas in your car, you could use completely clean energy. This is a big deal for regions moving away from fossil fuels and investing in sustainable infrastructure. There is a useful side to this technology that can't be ignored, in addition to the environmental and economic benefits. The compressed air engine is easier to build and maintain, which could be helpful in poor countries that don't have easy access to high-tech tools. This engine could help bring cheap, eco-friendly cars to markets that have been left behind by the EV boom by getting rid of the need for complicated manufacturing processes and expensive materials. Another big benefit is that it is reliable. It's less likely to break if there aren't many parts. People who drive these engines would find that they last longer and need less maintenance than other engines. The switch to compressed air engines is also in line with how energy is being made around the world. As more countries put money into green energy, it becomes easier to charge cars with wind, solar, or hydropower. In the future, when renewable energy is the rule instead of the exception, this technology will be indispensable. GM isn't just betting on a new kind of car when it uses this engine, it's also betting on a whole new way of thinking about energy and transportation. Last but not least, the price of these engines isn't just about how much they cost to make, it's also about how easy they are to get. Lower costs of making cars mean lower prices at the store, which could help people who normally wouldn't be able to afford one buy one. The compressed air engine has some promise, but it also has some challenges, as you'll see. The challenges of the compressed air engine. One of the main problems of this engine is how powerful and useful it is. Because it doesn't hold as much energy as standard fuels like gasoline, compressed air isn't very powerful. Early prototypes had trouble meeting the speed needs of daily driving, and most of them could only go about 90 miles. People who depend on their cars for longer trips or unpredictable plans can't use that kind of range. The power of the engine is another problem. For those who don't know, torque is the force that helps a car speed up and go up and down hills. Compressed air engines don't produce a lot of power because they work with low pressure. Because of this, they are not as suitable for some types of cars, especially bigger ones like buses and trucks. If these engines don't have enough speed, they can feel slow and weak, which won't make potential users feel satisfied. There's also the matter of safety. It's not as easy as it sounds to store high-pressure compressed air. Traditional steel tanks that were used in some versions are heavy and can be dangerous if they get broken. When the tank is under pressure, damage can be very scary for both the driver and people close. Thanks for watching. While you're still here, click on the other videos you see on your screen right now.